Hello, my student. Today we continue studying our differential equation course. And today we talk about homogeneous equation with constant coefficient. This is section 2, 2.3. Okay. Let's go. I have n orders homogeneous equation with constant coefficient. This means my equation is something like this. Minus 1 and minus 1 derivative here, plus and continue, plus last term will be y, a0, y, and y equals 0. This we call equation 1. We will not write all of them. We try found solution like exponential function, and because any order k order derivative for exponential function e to the power rx, it will be r power k e to the power rx. Plugging in our equation 1, we have, if we take out e to the power rx, we have a n r power n, a n minus 1 power r minus 1 plus continue plus a0 equals 0. Because exponential function is never equal 0, this means you have 0 need be equal this polynomial. Okay? Plus a0 equals 0. This equation we call characteristic equation, our homogeneous equation 1. And how now we have a couple of theorems. Well, how you know if you have polynomial nth degree, this means this polynomial have n roots. First situation, theorem number 1. If the roots r1 rn all real numbers and distinct, all real. This means all number you have only once. All numbers is different. Then function c1 e exponent 1 to the power x plus c2 e exponent r2 x plus and all this kind of sum, last one cn e to the power rx will be general solution our equation number 1. General solution first equation. Okay, looking some example. Proving this is solution, you can very easy, it's got to from how we build characteristic equation. Okay, let's go. We have third order differential equation, y second minus 10 y first equals 0. Now I write my characteristic equation. This is example number 1. It will be r cubed plus 3r squared minus 10r equals 0. We try factoring r out, r squared plus 3r 10 equals 0, r equals 0, and here we have r plus 5 r minus 2. And now I have for third order polynomial, I have three roots: r equals 0, r equal negative 5, and r equal 2. All three real number, all three different numbers. This means general solution my homogeneous equation will be c1 e to the exponent 0x plus c2 e to the exponent minus 5x plus c3 e to the exponent 2x. Well, here we can little bit simplify. This means y equal c1 plus c2 e exponent minus 5x plus c3 e to exponent 2x. This is our general solution. Now we maybe we have different situation. Maybe sum of root is repaired couple of times. Theorem number 2. What happened if we have repeated root? Roots. If characteristic equation 2 has repeated root, root r multiplicity k, this means it's repeated k times, okay, then part of general solution corresponding this root r is, we can write form is c1 plus c2 x plus c3x squared and plus ck x power k minus 1, and all of this multiplied by e to the power rx. One more time, this means part general solution our equation 1 with corresponding this root r, we can write this form. Okay. See some example. Let's go, we have example number 2, and then we have 9y to the 5th derivative minus 6y to the 4th derivative plus y to the 3rd derivative equal 0. We can write characteristic equation as will be 9r to the 5th minus 6r to the 4th plus r to the 3rd equals 0. R cube you take out, and we have 9r squared minus 6r plus 1. Okay. And what we have here? R equals 0 3 times. Second one, second factor, we can rewrite like 3r minus 1 square equals 0. This means r equal 1/3 2 times. Altogether we have 5 roots because power, our characteristic equation, maximum power is 5. Okay, great. This means now I can write my general solution. General solution is will be c1 c2x plus c3x squared formally I am writing only how we have in the formula. We have e to 0x power plus c4 plus c5x e to the x over 3 power. No, every time, because this part exactly equal 1, we can clear this part, and now we have, this is finally our general solution. But sometimes our polynomial have complex roots. What happened with this situation? Now we need to remember Euler formula. Okay. Euler tell us if you have e to the complex power, it will be e to the real numbers times e to the imaginary numbers power. For imaginary numbers, you have this kind of writing. I can write like cosine b plus I sine b. Use this fact and use fact for polynomial with real coefficient if have one is root is complex number. Okay, right. If polynomial with real coefficient has root a plus bi, then is automatically a minus bi. This means conjugate number. It's also root. Use this fact we can write this kind of theorem. Yeah, practically we're proving this theorem, but maybe it's a little bit more for proving we need. If our characteristic equation 2 has roots, complex root, this means we have a plus bi and a minus bi, then corresponding part general solution has the form e to the a power x c1 cosine bx plus c2 sine bx. How we can prove this fact? Let's go. We have two complex conjugate numbers. This means our solution will be a1 e to the a plus bi x plus a2 e to the a minus bi x. This will be maybe I'm doing this way, just a moment. E to the power ax take out, and here we have a1 e to the power ibx plus a2 e to the minus ibx. Use Euler formula, how we talked about before our theorem. We can rewrite a1 cosine bx plus I a1 sine bx plus a2 minus I a2 sine bx. Oops. Simplify and use new parameter. We can rewrite like e to the x times some c1. Oh, okay, maybe I write how it will be c1 come. It will be a1 plus a2 cosine bx. Plugging this is like c1 and plus I a1 minus a2 sine bx. This part we plug in like c2, and this means we prove our theorem. Now we're doing some example. Second derivative minus 4 times first derivative plus 5y equals 0. Here we have r square minus 4r plus 5 equals 0. Here we use formulas, and we have our r equal 4 plus minus square root 16 minus 20 over 2. It will be 4 plus minus 2i over 2. Right, standard form, it will be 2 plus minus I. This means our general solution, it will be e to the power 2x c1 cosine x plus c2 sine x. Remember, coefficient, exponential function, it will be real part, your complex number. Coefficient inside sine and cosine, it will be imaginary part, your complex number. Okay, this is general solution. We're solving our equation. Okay. Solving couple of example, we help you, I hope, help you make it your homework. For example, number 12. It will be y fourth order derivative minus 3 times third derivative plus 3y second minus y first equals 0. Write characteristic equation. It will be r fourth minus 3r cube plus 3r square minus r equals 0. Okay. Here we have r out, we have r cube minus 1. Here we have minus 3r square out. We have r minus 1, okay, equals 0, r minus 1. Now we have r times r square plus r plus 1 minus 3r sometimes this happens, sorry, equals 0. Okay, what we have? R equal 1, it's our first root, our characteristic equation. Here we simplify, we have r cubed plus r square minus 3r square, this means minus 2r square plus r equals 0. Maybe I need r take out, r equals 0. And here I have r square minus 2r plus 1. Equals 0. Okay, here will be r minus 1 square equals 0. This means r equal 1 twice. Oh. Twice. Okay, this means I have r equal 1 twice here and plus 1 more time. This means is 3 times altogether. Okay, my general solution is will be C1, this is give me from 0, and now I have 3 times r equal 1. This means I have plus e to the power x times C2 plus C3 times x and plus C1, C2, C3, C4 times x squared. This is our general solution. Okay. Solving next example. Well, for example, it looks very simple, but it have some problem. Y to the fourth order derivative equal 16y. Characteristic equation is will be r to the power 4 equals 16. It means r square equal 4 and r square equal negative 4. This means r equal 2, r equal negative 2, r equal 2i, and r equal negative 2i. I especially write this way when you can see you have all 4 different numbers, but 2 is real and 2 is complex. Okay, what we have here? Our solution will be C1 e exponent to x plus C2 e exponent minus 2x plus C3 cosine 2x plus C4 sine 2x. This is our general solution. Okay. Try solving some initial problem. Here we have number, I think it's number 24. It looks interesting. Okay, here we have twice y third order minus 3y second derivative minus 2y to the first equals 0. And then you have initial y from 0 equal 1, derivative from 0 equal negative 1, and second derivative in point 0 equal 3. First step we write characteristic equation. It will be 2r cubed minus 3r squared minus 2r equals 0. Okay. And then we take out r. So it will be 2r squared minus 3r minus 2. Okay, and consider factoring. I think it's 2r here and r there. Then we have minus 2. This means negative 2 multiplied by 1. And this is work. I have r equals 0. It's my first root. R equal negative 1/2. It's my second root. And r equal 2 is my third root. Okay, order your root is absolutely your choice. It's nothing changing if you write as different order. This means my general solution is constant, some parameter multiplied by e to the power x, negative x half, and plus parameter multiplied by e to the power 2x. Because we need solving initial point, we have general solution, but because we need solving initial point, this means we need found first and second derivative. First derivative will be negative 1/2 c2 e to the negative x half plus twice c3 e to the power 2x. And second derivative, it will be 1/4 c2 to the negative x half power plus 4 c3 e to the power 2x. Now we plug in x equals 0 for function, first derivative and second derivative, and build our equation. If you plug in x equals 0 for function, you have c1 plus c2 plus c3, and its need be equal 1. If you plug in for derivative, you have negative half c2, okay, plus twice c3, and this is need be equal negative 1. And for second derivative, you have 1/4 c2 plus 4 c3 plus 4 c3, and this is need be equal 3. Well, here you have system, linear system with 3 variable. Easy way, I think it's multiply, divide for something and simplify. And then if you're solving, you have, okay, c1 will be negative 7.5, c2 it will be 4, and c3 it will be 1/2. This means our particular solution with this initial point, it will be our solution is negative 7/2 plus 4 e exponent negative half 2 and plus 1/2 e exponent 2x. Okay. Doing one more example. That's question number 36 from our book. Thus we have this kind of problem. You have third order homogeneous equation plus 11y to the second plus 4y to the prime minus 14y. Here we need found general solution. Oh, I don't know what happened, sorry, equals 0. This we need found general solution, but we have sum of solution. We have y equal some part of this general solution, e exponent minus x sine x. What does this part show us? This means we have some complex number, and we can build this complex number. R1 is will be. Real part is negative 1, and imaginary part is 1. This means it's negative 1 plus I. Because our characteristic polynomial, it will be 9r third plus 11r square plus 4. Today's looks like not my day. 4r minus 11 equals 0. Oh, not 11, it's 14. You see? I'm okay. Equals 0. Because we have polynomial with real coefficient, this means we can write second zeros. It will be negative 1 minus I. Use this fact, use algebraic theorem about roots. We have r minus r1, it will be plus 1 minus I. Second, r minus r2 will be r plus 1 and plus I. Use formula for both multiplication. We have here r plus 1 square and minus I square. Whose will be r plus 1 square, it will be r square plus 2r plus 1, and minus I square, it gives us plus 1. This means finally we have plus 2 here. But because this is two numbers is root, this means our polynomial, we can divide for this polynomial. Okay, without any remember. Try. 9r cubed plus 11r square plus 4r minus 14. We divide by r square plus 1, 2, 3. I'm okay. 2r plus. Okay. Now start use long division. We have 9r. It's give me 9r cubed plus 18r square and plus 18. If we subtract, it will be minus 7r square, 18r here, and minus 14. Believe me, here's 14r and minus 14. Looks like we need to take it minus 7, and this means we have exactly what we need. Minus 14r minus 14. this is 14, and we have 0. Finally, what we have? What kind of information we have? We have r first is minus 1 plus I, r second minus 1 minus I, and our third, what we found now is a result our division 9r minus 7 equals 0. This means 7/9. And now we can write our general solution. It will be e to the minus x power c1 cosine x plus c2 sine x plus c3 e to the 7/9 power x. Okay, solving, I think it's 2 more example. One example is number 42. Here we have general solution, and we need to build linear equation, homogeneous equation whose solution we have. Okay, what we have here? We have our solution, general solution is a plus b x plus c x squared times cosine 2x plus d plus e x plus f x squared sine 2x. Okay, what kind of information we have here? First, roots is complex number and only imaginary part. Second, each roots here we use 3 times because we have polynomial second order for multiplied per function cosine and sine. This means you have root r equal 2i and r equal negative 2i and 3 times. Okay, this means r minus 2i times r plus 2i, and because it's 3 times you have cube here and equals 0. Okay, first multiply it, it gives us r squared plus 4, and this is third power equals 0, and distribute we have r to the 6th power plus 3 times r to the 4th time 4. Okay, maybe I'm writing here is very difficult time right now. It's 3 times 4, it will be 12. Then plus 16 times 3 will be 48 r squared, and plus r 4 to the 3rd power, it gives us 64 equals 0. Now I'm ready for write my equation. This is characteristic equation. This means we can write 6th order derivative plus 12 times first one plus 48 second derivative and plus 64 y equal 0. We have solution and we build differential equation. Okay. And last one but not least, number 58. What is interesting here? This is practically not a homogeneous equation, because here we have not constant coefficient this means? Sorry. We have x cubed times 4 third derivative plus 6x squared y second derivative plus 7x y prime and plus y equals 0. Y equals 0. Okay. We did something similar here, but it will be a less order. Okay. Let's go. We have substitution v equal natural logarithm x. And here function y, its function depend v, depend x. This kind of. This means first derivative, it will be derivative our function respect variable v times derivative v function. It gives us 1 over x. Second derivative, it will be derivative v times 1 over x. Okay, I'm right this way. 1 over x, 1 over x. And minus 1 over x squared y to the. Or it will be v second derivative, twice derivative here, 1 over x squared minus 1 over x squared y respectively. Okay, and now we need third derivative found. It will be y v. Sorry, you need to write it 3 times. And 1 over x cubed, because 1 over x times 1 over x squared, and minus 2 over x cubed second way, minus 2, but here we have minus, it will be plus 2 over x cubed y to the v, and minus 1 over x cubed y v. Okay, this means we need simplify too a little bit. It will be third derivative respect v 1 over x cubed minus 3 times over x cubed second derivative and plus 2 times over x cubed y. Now plugging what we have in our equation. Okay, third derivative we multiplied by x cubed in the formula. This means we have third derivative v minus 3 times second derivative and plus first. Okay. Then we second derivative need multiplied by 6x squared. What does give us? It's give us plus 6y second derivative respect v minus 6 first derivative respect v. That's it. And then we 7 times first derivative. This means only 7x. It will be give us plus 7 y to the v, and then we need add our y plus y. Okay. Finally, we write. Okay. This is our equation. If we rewrite, this will be third derivative. Second derivative minus 3 plus 6 is give us plus 3. Minus 6 plus 2, this means give us, just a moment, where is it? We have minus 6 plus 2 minus 4 and plus 7, this means plus 3 and plus y. Okay, bingo, we have homogeneous equation with constant coefficient. This means our characteristic equation will be r to the cube plus 3r squared plus 3r plus 1 equals 0. Okay, looks like we have r plus 1 cube equals 0. This means we have r equal negative 1 3 times. This is very important here. This means our function depend v. It will be c1 plus c2v plus c3v squared times e exponent minus v. But v is not variable what we're solving. It's something will help us. Okay? This means what we do doing. We need doing go to back for our old variable, and because v is natural logarithm x, this means our solution will be c1 plus c2 natural logarithm x plus c3 natural logarithm x all together square, and e exponent minus natural logarithm x, it gives us 1 over x. All of this multiplied by 1 over. This is our general solution.